Hi guys, so today we'll be looking at how to find the inverse of this particular 3 by 3 matrix. So it's done in steps and we're going to be using, of course, the cofactor method. So the first thing you need to do is we need to find the determinant. So let's find the determinant of this matrix, then I'll show you how it will proceed. So finding the determinant, we simply say we set up plus minus plus on top like that. Then we're going to get each value in that particular row. So the first value that we have is 7. So we can have our 7 here like this. Then let's form the 2 by 2 that is created, excluding the row and column for 7. So the 2 by 2 that is formed when you exclude those two. So we have -5, 1, -4, and 8. The next value is -6. Now remember we said we set up a plus minus plus, then we have -6 and a negative there. Hence that becomes a positive. So what will be the 2 by 2 formed in this case? Again, it's the same thing. You hide the row and column for that particular number. Hence we'll have 4, here 2, here -4, here 8. Okay, and lastly, the last value that we have there is a 3. What's the 2 by 2 formed? Same concept, 4, 2, -5, 1. Okay, so now let's find the determinants of these particular 2 by 2s that we have. So we're going to say 7, -5 times 8 is -40. 1 times -4 is -4. Plus, so we left out a 6 here. So plus 6. Then 4 times 8, simply get 32, minus 8 times, 2 times -4 is -8, plus 3, 4 times 1 is 4, minus 2 times -5 is -10, like that. Okay, so let's see how it proceeds. So here we have 7 multiplied with, so 40 and -4, simply get -36. Then plus 6. Here we have 40, like that. Then lastly there we have plus 3. In the brackets we'll get a 14, like that. So now let's just expand and then add everything. We see what we get as our inverse. Sorry, as our determinant first. So 36 multiplied by 7, we simply get a -252 plus, so 40 by 6, we get a +240. And lastly, 14 multiplied by 3, we get a +42, like that. So if we add all these values together, what we're going to get will be a +30. So the determinant of this matrix A is equals to 30. So this is the first step. Step number 1, find the determinant of the particular matrix, of which we've done. The next step now is to find the cofactors. So let's go ahead and find the cofactors. Okay, so we're back to our matrix A. So to find the cofactors, we're going to be picking each particular digit in this case and creating a 2 by 2 matrix. So for example, if we pick the first value, which is 7, we're going to hide the row for 7 as well as the column for 7. So whatever remains creates the 2 by 2 that we're looking for, just like that. Another example is, for example, if you pick a 4 that is here, we're going to hide the row for 4 as well as the column for 4, like that. Then whatever values are remaining will create our 2 by 2 matrix that we're looking for. So to do that, we're going to have a very big matrix. So we need a very big matrix. Yeah, something like this. So let's create our 2 by 2 matrices, and this is what will give us our cofactors. So we have this. So at this position, of course, there's a 7 there. So at this position, if we put if we exclude the row and column for 7, the 2 by 2 formed will be -5, 1, -4, and 8, like that. If we move on to the next number, which is 4, if we hide the row as well as the column for 4, the remaining values is what gives us the 2 by 2 we're looking for. So the remaining values, of course, will be, let me use the same color. The remaining values will be negative 6, here 3, 1, 8, like that. I hope you get the concept now. Same thing for this particular matrix here, we'll have negative 6, negative 5, 3, and negative 4. Okay, so let's move on to the second column. So this is our second column. So in the second column, what will be formed here? Everything excluding this row and this column. So we have 4, 2. Here we have negative 4. Here we have 8. The next one is at 5 there. So excluding the row and the column, we have 7, 2, 3, 8. The next one is 1. Row and column excluded. So 7, 4, 3, negative 4. Let's include the last column like this. Okay. So the 2 by 2 that will be formed here will be 4, 2, negative 5, 1. At this position, the 2 by 2 formed will be 7, negative 6, 2, 1. At this position, we have 7, 4, negative 6, and negative 5. Okay. So we have filled up everything, and this is what we have. Now, there's something that you have to know about the signs. Given a 3 by 3 matrix, like the one that we have just here, you have to know that here you can have plus, minus, plus, minus, plus, minus, plus, minus, here we have a plus. Okay, so based on these positions, this matrix should be a positive, this matrix here should be a negative. So this one here negative, this one here negative, this one negative, and this one negative as well. So whatever determinant we're going to find at this position, we're going to include the negative part as well. Then if it is affected, it will obviously change. So now the next step will be to find the determinant at each position. We're finding the determinant at each position, and this is what we're going to get. So let's go into that. So the first matrix that we have, which is this one here, we can say negative 5 by 8, let's just say negative 40 minus negative 4. So the determinant there will simply be negative 36. So we write our negative 36 right here, negative 36. We move on to this matrix here, which we're going to say 4 times 8 is 32 minus negative 8, like that. So we're going to get a positive 40. Now remember, there's a negative outside, has to become a negative 40 instead, like that. And the last one is 4 times 1, which is a 4. Then 2 times negative 1, sorry, negative 5 is negative 10. Like that. If we add the 2, simply get 14. So that's basically the idea. So the next thing now we're going to do is find the determinant at each position. So let's go ahead. At this position here, we have negative 6 times 8, that is negative 4h, minus 3. So this should give us negative 51. Now remember, there's a negative outside, hence we get a positive. So in here, positive 51. Let's find the determinant here. 7 times 8, that should be 56. So 56 minus 6, the product of these two, hence we get 50. So here we have a 50. We come to this matrix here, 7 times 1, that is a 7. 2 times negative 6, so that was negative 12 in brackets. So what we get here will be 19 positive. But remember, there's a negative outside, hence that is negative 19, like that. The next step is this one here. So we can also say 6 times 4, negative, negative, that is positive 24, minus negative 15, like that. So again, just similar to what we've been doing, we just put them together, and what we get will be a positive 39. So here we have positive 39. We come to this matrix here, 7 times 4 should be negative 28. So negative 28 minus 12. So this should give us a negative 40, if I'm not mistaken. Now remember, there's a negative outside, hence this will become positive 40. The last part, which is this one here, 7 times 5 is negative 35. Then 4 times 6 is negative 24, like that. So this becomes negative 35 plus 24. So subtracting the two, we should get 6 plus that, get a negative 11. So this here is negative 11, like that. So after finding all these values, these are the cofactors that we're finding. After finding all these values, what we're going to do is, this matrix that we have here, we are going to transpose it. Transposing this matrix that we have will give us the adjoint. So the adjoint of matrix A will be equals to the transposed cofactors. So let's transpose it. So the row becomes the column becomes the row. So the first row is negative 36, negative 40, 14. That becomes the first column. The second row, 51, 50, negative 19. The third row, 39, 40, negative 11. So this is what we have. So once we transpose this, what we get is the adjoint of A. Now remember, so far we have the determinant and the adjoint of A. Combining these two using the formula, we get our desired answer, and that is the inverse. So let's combine the two. Okay, so from the beginning of the video, we had to find the determinant first, and the determinant we found to be 30, and this is our adjoint after going through all the cofactor process. So now, the formula for the inverse is given by the inverse of A is equals to 1 over the determinant of A multiplied by the adjoint of A. So this is what we have. Let's do this here. So let's just do the substitutions in this case. So this will give us 1 over 30. The adjoint of A is this matrix that we have here, which is negative 36, negative 40, 14, 51, 50, negative 19, 39, 40, and negative 11. That's what we have. Okay, so now we are multiplying 1 over 30 times everything in this matrix, and we can reduce where we have to reduce. So A inverse will be equals to, so we'll have negative 36 over 30. Next thing will be negative 40 over 30. And lastly, we have 14 over 30. 51 over 30, 50 over 30, and negative 19 over 30. Last part there we have 39 over 30, 40 over 30, negative 11 over 30, like that. So with this now, we can reduce where we can. So for example here, we know that 6 can go into 36 and 30. So our final answer will look like this. 6 into 36 is 6. 6 into 30 is 5. So 6 over 5. 10 into 40 is 4. Into 30 is 3. So negative 4 over 3. Here 2, that will be 7 over 15. Here we have a 51 and we have 30. So 3 into 51 we have 17. 3 into 30 we have 10. When we come here, we can just cancel the zeros, hence we have 5 over 3. We come here, we'll leave it as it is, 19 over 30. Here we can reduce it by including a 3 into both. So 3 into 39 should be 13, into 30 should be 10. Here we cancel the zeros, we have 4 over 3, and lastly, this can remain as it is, which is 11 over 30. So this is the inverse of that particular matrix A that we had. So remember, the first step, let's just quickly go through. The first step is to find the determinant, that is our matrix A. Find the determinant. The second step after finding your determinant is to find the cofactors. After your cofactors, whatever you have here, you transpose. If you transpose this, what you get is your adjoint. Then once you have your adjoint and your determinant, you just come and apply this particular formula that we have here, and that gives you the inverse of this matrix. So in case you have a question, please feel free to drop it in the comments. Thank you very much.